All right, hello. So this is the video here for section 6.1. The goal here is you'll watch this video for today's 6.1. There will be a video for tomorrow, 6.2. And then I should be back no later than Monday is the plan here. So, this will go over 6.1 notes, and then tomorrow will be 6.2, and then I'll be back on Monday. So, okay, let's get started. So, 6.1, Unit 6 is about square root functions. So all of Unit 6 is about square root functions. So section 6.1 is going to be specifically about the graphs of square root functions. So graphs of square root functions. Okay. In order to get a good grasp of the basics of the graphs of square root functions, we should start with the parent function. So again, all functions have a parent function, right? You could think of the parent function as what all other functions derive from, right? So all other square root functions come from this basic parent function, right? So the parent function for square roots is as follows. It's f of x equals square root of x. Now, in order to see what this graph looks like, let's make a table, and then we'll kind of use that to get a basic sketch of what this square root functions look like graphically. Now, you'll notice if I take an x value of, say, -2, right? If I plug -2 in for x here, this would be the square root of -2, right? If I put -2 in for x here, I get the square root of -2. Now, the square root of -2 is an imaginary number, which does not exist on the real xy grid. So this would be does not exist. So this would be none, okay? That's actually nothing in terms of the xy grid, right? If you were to type this into the calculator and go to the table, the TI-84 or Desmos would say something like undefined or error or something like that, okay? Same thing with -1. This would be the square root of -1, which again would be nothing, so none. That would not be on the real number system, so which we can't see on the xy grid. If I plug 0 in for x, square root of 0 would just be 0. So 0, 0 would be a point on our xy grid. So let's sketch this out. So 0, 0 is a point. So 0, 0 would be here. Let's plug in an x value of 1. This would be the square root of 1, which is just 1. So 1, 1 would be a point on our grid. 1, 1 would be there. Now, if I plug in an x value of 2, I'm going to get the square root of 2, which is a nasty decimal. So what I'm going to do is skip down to 4, because if I plug in 2, I'm going to get a nasty decimal. If I plug in 3, I'm going to get a nasty decimal. But if I plug in 4, then the square root of 4 would be 2. So that's nice and easy to calculate and nice and easy to graph. So I'm just going to skip down to 4. So 4, 2 would be here. Okay, so now we see that this will kind of continue. This pattern will continue in this way. So it'll get this kind of graph that looks like that. Notice that there's not an arrow. There's no arrow going this direction. And you can see that because here they don't exist, right? So this is not an arrow going here. It starts here. So you could think of this as like the starting point or the initial point, if you will, right? There's an initial point and it does not go further in the other direction, right? It only goes in this one direction, and that would be it, okay? So this is the parent function for all square root functions, right? So when we talk about transformations in a minute, we're going to be talking about if it shifts left 2, it'll be this exact graph shifted left 2. That would be left 2, right? If I say it's been shifted down 1. It would be this exact graph shifted down 1, right? So it's this exact graph that all transformations derive from, right? That'll be a really important thing to understand is know this graph well, okay? Okay, so next let's talk about the transformation form. So transformations. So standard transformation form for a square root function would be f of x equals a times the square root x plus or minus h and then plus or minus k. So this is the basic transformation form for a square root function. It's also the basic transformation form for pretty much every function we've learned in the whole year and will continue to learn, right? It's a very similar set of rules that we've seen over and over and over again, okay? So let's break down each piece here. So the a value can do one of three things, or a combination of three things. So if the a value is negative, so if the a value is like a -2, right? That would cause a reflection over the y-axis, over the x-axis, okay? So it's a reflection if a is negative, okay? If a, the number a, is greater than 1, this would cause a stretch. And again, we've seen these rules before. None of these rules should seem weird or unusual, right? If the a value is between 0 and 1, so if it was like 1/2 or 2/3 or something like that, then this would be considered a compression. Okay. Now, a stretch in terms of visually, what that looks like is it'll just kind of make it taller, if you will, right? A compression will kind of make it shorter. Right? So if you want a visual word, a word that describes the visual there, that would be a fine way to describe it. Okay, so again, these rules should not be new. We've seen these rules before. So in here, the x plus or minus h will make it go left or right. So if it's x plus h, then that will go left h units, right? So if it's x plus 2, the graph will go left 2, right? If it's x minus h, it will go right 2. So if it was an x minus 3, the whole graph would just shift right 3. And then finally, this k value, if it's a plus k, so if it was a plus 2 at the end, it'll go up that many places. So this would go up. If it's a minus k, then like a minus 3, it'll go down 3. So a minus k would go down. So these are the set of rules that we've seen in the past regarding transformations of any function, right? And so it also applies to square roots. So let's look at an example. Okay, so let's say you had the following function, f of x equals -2 square root x plus 2 and then minus 3. Oops, those are my dogs. Hold on. Okay, so yeah, so let's say we have this this function. Okay, so first let's identify the transformations. So in this case, the a value, first the a value is negative. So this will cause a reflection. Next, the 2 here is bigger than 1. So 2 is bigger than 1. So this is going to be a stretch, right? So if the a value was bigger than 1, it's a stretch, right? 2 was bigger than 1, so it's a stretch. Okay, then inside here, the x plus h is x plus 2. So this will go left 2. And then finally, the k value would be this minus 3. So it's a minus k, so it'll go down 3. Okay, now when you're actually graphing these things, here's how you should do this. When you're actually graphing them, here's what you would do, okay? These two transformations find the starting point from the origin. Okay, those two find the starting point from the origin. So in other words, I'm going to start at the origin, and then I'm going to apply those two transformations, and that's the starting point for this graph. So if I go from the origin, if I go left 2 and down 3, that would be my new starting point. Okay, so from the origin, I go left 2 and down 3. And so that is my starting point, okay? Then from there, you're going to think of this A value here. You're going to think of this A value as the slope to the next point, right? So the A value is kind of like a slope that can find the next point, right? Now, just be very careful. It only finds the next point. It doesn't find future points. So just use this to get one additional point, and then you can make a basic sketch, okay? So here we've got the quote slope is down 2 over 1. A slope of negative 2 would be down 2 over 1. So if I go down 2 over 1, right? So I go down 2 over 1. That takes me to my next point, right? And then from there, we should have a graph that has this basic shape, but it's been reflected. So it's a reflection. So it's got that basic shape. Reflected is going to be like that. So that's going to be the basic idea of these graphs. It always kind of goes from the starting point to the next point and then kind of curves off to the side. So that's going to be the basic shape of these things. So again, you use these two to find the starting point from the origin, and then you can use this A value here as kind of like the slope to the next point, right? Okay, so that's the easiest way to graph these things. If you really get into a bind, you can type it in a Desmos and get some points from there. But honestly, that's slower than just using the transformations. But yeah, you could technically do that if you really get into a bind, okay? Okay, last thing I want to do on these examples is we're going to find the domain and range of these graphs. So again, domain is the x values from left to right. So if I start on the left side, this is the leftmost point, and that has an x value of negative 2. So my domain starts with an x value of negative 2, and then my graph goes right forever. So the right side of this graph, the x value as I go to the right forever would be infinity. So this would go from negative 2, starts at negative 2, and then it goes forever to the right. So my x values would be from negative 2 to infinity. My range, right, are my y values bottom to top. Bottom to top, my y values least to greatest. So the bottom of this graph, well, the bottom of this goes down forever. So the bottom of this graph would actually go down to negative infinity. So the bottom y value, the lowest y value is negative infinity, right? So if I start at negative infinity all the way down here, I'm moving up a little bit, moving up a little bit, moving up a little bit, and then this is the top point of my graph. This is the highest y value. So this highest y value is here at 1, 2, 3, negative 3. So the highest y value is negative 3. So that would be the top of my range, like so. And so that would be the domain and range of this. Okay, let's try another one. Number 2, let's do f of x equals 1/2 square root x plus 2 and then minus 1. Okay, so let's identify the transformations. So this A value is just a 1/2, so it's not a reflection because it's positive. So it's just 1/2. Now 1/2 is between 0 and 1, right? And if the A value is between 0 and 1, this is a compression. So it's called a compression. This x plus 2 would go left 2 according to the rules above. And then this k value would be minus k, so that's down 1. So we've identified the transformations. Then to actually graph it, you'll use these two to find the starting point. And then you'll use this A value as the slope to the next point, right? So you use these two transformations to find the starting point, and then from there you can use 1/2 to get to the next point on the graph. So let's go ahead and do that real fast. So we've got my starting point from the origin. Okay, start at the origin, go left 2, okay, and then down 1, and that is my starting point. So that's my starting point for this graph. Then you can use this A value of 1/2, so up 1, over 1, 2, and that is your next point. And then just kind of follow that basic shape. It goes to the point and then kind of off to the side at a slow curve like that. And so that would be the graph of this function. Now again, if you needed additional points or if you wanted to make sure, you could type it into Desmos and see additional points. I'm fine with that. But honestly, it's slower to do that than it is to just use the transformations. But anyway, that's the basic graph there. So now that we have the graph, we can find the domain. So again, the domain is the x values, least to greatest, which means we go left to right. So this will go my left side, my farthest left x value is here at -2. So it starts at -2, and then it goes from there, it goes right forever, which goes to infinity. So my domain would go from -2 to infinity, and my range would be the bottom y value or lowest y value. So my lowest y value is at -1. My highest y value would be up to infinity. So my range would go from -1 to infinity. Okay, let's do one more graph one. All right, number 3, f of x equals 3 minus 2 square root x minus 1. Now, the reason I wanted to do this is because this one tends to trip people up, right? So here's my square root. The a value is the number attached with multiplication to it. So the a value is the -2, okay? The h value would be this inside here, which makes the 3 the k value, right? So to avoid confusion, what I'm going to do here, right, is I'm going to rewrite it. So the a value is -2, so it's just -2, and then square root x minus 1. The k value is this +3. So I'm just going to write it at the end, plus 3. These two things here are the same. I didn't change this at all. I just rewrote the +3 at the beginning at the end, right? And so now this is a little bit easier to identify transformations, okay? So now let's identify the transformation. So not only is my a value negative, so this a value is negative, which means it is a reflection. The number 2 is bigger than 1, so the a value is bigger than 1, so that also means that this is a stretch. Then inside here is an x minus 1, which means it'll go right 1. And then here is a k value of +3, so that'll go up 3. Now we're going to use these two transformations here to find my starting point. I'll just call it SP. And then this A value in front will be my slope. This -2 here will be my slope to the next point. Okay, so let's sketch it out. So we have from the origin, my starting point goes right 1 and up 3. And so that gets us our starting point here. Then I have an A value of -2, so that's kind of like a slope to your next point. So slope to your next point would be -2, so that would go down 2 and then over 1, and that would get you your next point. And then from there, you just start with your starting point, and then you go to the next one, and then you kind of follow that same curve off to the right that we've seen on all these. And so that's the basic shape of this graph. Okay, so then the domain of this, so the x value, least to greatest, left to right, would be starting at 1, and then it goes right forever, so 1 to infinity. The range is my y values least to greatest, so y values bottom to top. The bottom goes to -infinity, so the bottom goes down forever to -infinity. The highest y value is here at 3. And so that would be my range. Okay, the last kind of question I'm going to ask on the assignment is not graphing it, but just identifying transformations and writing equations from it. So the last example here is, let's say I give you transformations, okay? So if I give you transformations of down 4 and right 2, okay? If I give you those two transformations, can you write a square root equation that has them, right? So down 4 would be our k value of -4. Right 2 would be that h value of x minus 2. So a square root equation that has this transformation would be f of x equals, the a value is just going to be the normal 1, and then square root, the right 2 would put an x minus 2 inside, and a down 4 would put a -4 at the end. And we're done. So we've written a square root equation that has the given transformations. Okay, let's do one more real fast. Let's say I gave you, there was a, let's do a, I'll do this one. So if I say a compression on the assignment, some of them might say shrink. It's the same thing. It means the same thing. A compression or shrink, right, by 2/5, right? And then let's say it goes left 5 and up 1. So I'm giving you these transformations. So this means that our A value is 2/5, okay? Then the left 5 means inside we're going to have x plus 5. And then up 4 means our k value would be, up 1 means our k value would be +1. So then a function that has this would be f of x equals, my a value is 2/5. That produces a compression or shrink by 2/5. Then square root of left 5 would be x plus 5. And then up 1 would be +1. And there we go. That is a square root function that has these transformations. Okay, so on the assignment, you'll have some questions that look like this, where I give you transformations and you need to give me this kind of function. I'm also going to give you questions where I give you an equation and you just need to tell me the transformations. And then finally, I'm also going to ask you to find the transformations and also sketch the graph and also find the domain and range. So you'll have all kinds of questions like this on the assignment. Okay, so that is 6.1.